Good morning, our matriculants. It's good again to be with you today. I hope you have been enjoying the sessions ever since we started. It's a countdown. We are coming closer and closer to that exciting time. Finally, we are sitting for our grade 12 examinations. I'm sure we are fully prepared. I'm sure the sessions are very important to us can make us aware of the small things that we need to consider as we prepare for the examination. Our greetings will not be complete. We know with us in mathematics, the only complete greeting that we can do is when we have an exercise just to make sure that everybody is well awake. It is an inequality. The question there says solve for x. I want us to all do this together. Don't write anything for now. I know you have your pens and papers ready. You're already trying to scribble something. Let us just make sure that we all agree on this that we have here, all of us. To solve for x, of course, we need to first write this thing in a standard position. Mean that the 2x squared, we get its additive inverse, then it becomes negative 2x to the power 2 minus x plus 3 is less than 0. Then our expression now is, our inequality is now in standard position. But the advice is, don't let the coefficient of x squared to be negative. Do you see that negative 2? Let's get rid of that negative 2 as the coefficient. How are we going to do that? You know that we'll have to divide everything by a negative. Every term must be divided by negative. And if that happens, we have here a positive 2x squared. This now becomes positive x. This becomes negative 3. Very important. Don't forget that now the inequality sign now changes to be greater than 0. It has been less than, but because we have divided every term by a negative, the inequality sign changes to be a greater than 0. Look, we can factorize here. But remember the secret that we talked about last time to say the power of the quadratic equation. It makes things easier for us. And if you use the quadratic equation here, because we need the critical values, you know, remember the quadratic equation, b squared minus 4ac, all is divided by 2a, and the value of b here is 1, so you have negative 1 there, plus or minus. You have the 1 to the power 2 minus 4, your a is 2, and your c is negative 3. All this is divided by 2 multiplied by a, which is a 2. If you simplify further, negative 1 plus or minus, you can use a calculator here, and I'm sure a calculator will give here 4 multiplied by 3, 12, 24, it becomes positive. You have 25 there, all divided by 4. The square root is minus 1 plus 5 over 4, or the other value of x becomes a negative 1 minus 5, all also divided by 4. And finally here, our answer becomes a positive 1. I'm sure you agree about that. And here our answer becomes a negative 3 over 2. Now this becomes our critical values. And remember we said you can just use that number line. The number line, we remember that because these are our critical values, we put them on the number line, negative 3 over 2. And on this side, it is always plus, minus, a plus on this number line, especially because the coefficient of x to the power 2 is a positive. Once, because we are all going to make it a positive, then for our number line here, it is, don't forget it, it is always plus, minus, and a plus. These are our zeros. These values are our zeros, because when we substitute them in our factors, they will give us a 0. Now the area now on the number line, where this inequality is greater than 0, Greater than 0 is the positive area. Positive is greater than 0. Greater than 0 is this positive area on our number line. Your solution set, then you can just write there x is less than -3/2 or x is greater than 1. All the values on the number line going to the right are greater than 1. Remember, all these values here on the number line, from 1 we have 2, 3, 4, 5, all those values are greater than 1. But here on -3/2, all the values on the number line, as you go to the left, all these values are less than -3/2. That is why our solution said we have x is less than -3/2. I'm sure you now are well awake. Everybody have settled down very nicely now. You are now ready with your pen and pencils. I want us to note the use of a quadratic equation, because sometimes for many of us it may be a bit tricky to factorize this quadratic expression here. Well, the factors for those who might have factorized it is 2x plus 3 as well as x that is greater than 0. But if, because sometimes we commit a lot of mistakes when we factorize here to get the factors here, the quadratic formula comes in very handy to assist us to get our critical values. This side is not the solution set, it is just the critical values, and the critical values we have that plus minus plus on the number line, and then we can also use the graph, because remember this is a quadratic expression, so we can actually use the graph as a tool to find the solution set. Now that everybody has settled down, let's grab our pen and pencils and we answer the same question on this one now. 15x minus 4 is less than 9x to the power 2. It is still what? A inequality. It is still an inequality. Can now encourage that everybody, I'm going to give you 3 minutes to work on this important 4 marks. We need it in our people on this 4 marks. 15x minus 4 less than 9x to the power of 2. I will give you these 3 minutes then to quickly work out, and you can feel free when necessary to use the quadratic equation to find the critical values. 15x minus 4 is less than 9x squared. Always can't talk a lot in maths. I remember the first time we started, I said it's not time to talk. Your teachers have been talking a lot from January, from ever since you started with grade 1. Now is the time to put our talk down on pen and paper. Let's do that. The same question, solve for x. The question is still the same, solve for x. But we realize an inequality. Right, I'm sure you have worked it out nicely there. You checked with the person next to you and you agree about the answer. Step by step, we took first this 9x squared, the additive inverse of it. Then we have it as negative 9x squared. And you can see now our expression is now in a nice standard position. But we don't like this coefficient of x squared to be a negative. So remember what we do, we divide it by negative, each and every term divided by negative, and once you do that, your inequality sign changes now. It was less than 0, it is now greater than 0. It's very important, let us not forget that one. Our powerful tool, which we find in the formula sheet. Remember this formula, we talked about it. You find it in the formula sheet, the quadratic formula, and then you substitute in there the value of b, negative 15. It becomes positive, negative by negative, positive. Here is b squared, 4ac. The value of a is 9, the value of c is 4. You simplify it, your calculators can help you a lot there. 15 plus or minus the square root of 81 divided by 18, because the 2a was 2 multiplied by 9, which is 18. Then ultimately you have your values there as 4 over 3, or the other value is 1 over 3. You put them on the number line. It is always plus, minus, plus for your number line. Plus, minus, plus. Don't forget that these are your 0 points. The area where this expression is greater than 0. Greater than 0, it is a positive. Remember, a negative is less than 0, but a positive is greater than 0. The positive is the one which is greater than 0. Then you can write nicely your solution set. X is less than 1 over 3. All the values that goes this way are less than, or x is greater than 4 over 3. X is greater than 4 over 3. We did talk about that on the number line. All the values to the right are getting greater and greater and greater and greater. But on the number line, all values to the left are getting smaller and smaller and smaller. I hope you had it nicely done as a warm-up to start the session today. And I want to appreciate all those who are around to share this exercise with us. This is a 4 marks, 5 marks question. We are happy about it. We are sure. We are waiting for the examination on paper 1 to start, and then we work on that exercise. Today, my learners, we are actually going to continue with what we did on paper 1. We are going to continue with what we did on paper 1. Now, on paper 2, by the way, because yesterday we were doing paper 2, remember, data handling, we are going to continue with it today, data handling. With our focus point for data handling today will be about grouped data, where we will do the OGIF graph, the cumulative frequency graph, the histogram. We'll also mention the frequency polygon, as well as drawing a box and whisker using the grouped data. We'll ultimately end up talking about the scatter plot. Right. The exercise we have, the exercise we are going to start with will be an exercise like this one here. As an example, this will be our example, the exercise, just to start our discussion. It says here, the time taken in minutes, this time is written in minutes, to complete a 5-kilometer race by a group of 10 runners is given below. The first runner took 18 minutes. The first runner took 18 minutes. Let us not write for now. We just look at this and we talk about it. The second runner, 21 minutes. The other runner, 16 minutes, 24 minutes, 28 minutes, 20 minutes, 19 minutes. Again, the other one also took 19, 23 minutes. They say there must be 10 runners. 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like I've skipped one of the 20. We must have 2 20s here, so that there are 10 runners. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 runners. Now the first question says, just calculate the mean taken to complete the race. I'm sure we talked about this yesterday. The mean is we add all the data that we have here, and as we do that, to answer the question much easier, you need to arrange these numbers. Arrange them. Numbers from the smallest to the largest one. That is very important. Always arrange your data from smallest to the largest one. Now the first question says calculate the mean. We can use the calculator to calculate the mean. And for the calculator, we will go mode. It shows two statistics, and we go one variable. There it is. Let's try it again. We said it will be two statistics, and we go one, a variable. We didn't want this as yet. But in the meantime, you can just add. You can just add these. You can just add these numbers, 18, that. And we know that for the mean, after adding them, we divide by the number of terms we have there. We divide by the number of terms we have there. We said on the calculator it will be mode 2 statistics 1 variable. There it is. Then we can enter our data. 18 is equals to 21 is equals to 16 is equals to 24 is equals to 28 is equals to 20 is equals to 20 is equals to, we have two 19s, 19 is equals to, the last term is 23. There we have entered all the data we have. We go AC, shift, and 4 is variables, and 1 is number of terms, but 2 is what we are looking for, which is the mean. 2, we press 2, the mean is equals to, and it gives us there that the mean is 20,8. I'm sure this is the number you have as well, 20,8 as the average in minutes for the runners to complete the race. Why did I do it with a calculator? It's because question 2 now says calculate the standard deviation. The standard, question 2 now, calculate the standard deviation. Because already you have your data in the calculator, you just go AC and shift. On 1 it is statistics. We again 4, you can see 4 there on the screen of the calculator. Now 3 is our standard deviation, 3 the standard deviation, and our standard deviation then becomes 3,25 when we correct it to 2 decimal place. 3,25 corrected to 2 decimal place. So we have, using the calculator, calculated the standard deviation. We also have calculated the mean. What I actually want us to talk about is question 3 that says how many runners completed the race within 1 standard deviation. Let me write it here. Within 1 standard deviation. How many runners completed the race, but that they did it within 1 standard deviation of the mean? This they did it within 1 standard deviation of the mean. That is what the question says now there. How many runners, if you can all look at this, how many runners completed the race within 1 standard deviation of the mean? Good. Now for that question, we remember that to calculate the number of, we are going to use the mean minus standard deviation and the mean plus the standard deviation. Good. It is only one here, standard deviation, one standard deviation. But if the question said, for instance, 2 standard deviation of the mean, then for instead of this one, we are going to write 2 standard deviation, 2 standard deviation. Then it means we have here the mean, we said it is 20,8, subtract the standard deviation. The mean is 20,8 plus the standard deviation. What we have there is plus 20. We will have here 24 point, we said 20.8 minus 3.25. It actually give us there, when you use your calculator, 17.55, and on this side we have the mean, which is 20.8 plus the standard deviation 25, which is equals to 24.05. There it is. Now this is our interval. We want all the runners with meanest between these two values. All the runners with meanest that falls between these two numbers, 17.55 and 24.05. Let's check on our data. 17.55, we have 17.55, it's 1. It is within the interval 17.55 as well as 24, 1.05, 2. Right. Remember, it should be between 17.55 and 24.05. So this number is bigger than 17, it's okay. This number is also bigger than 17, it's okay. This number is also bigger than 17, and it is less than 24.05. And this one is out. This number is bigger than 17. That one is bigger than 17. This is bigger than 17. Bigger than 17. Bigger than 17 and less than 24. The numbers are between 17.55 and less than 24.05. We are looking for those numbers, those athletes with the minutes between 17.55 and 24.05. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 runners. 8 runners who completed the race within 1 standard deviation of the mean. I'm sure it was a straightforward exercise. We used the calculator. The calculator made things much easier for us to calculate the mean, to calculate the standard deviation, as well as to calculate the number of runners that had minutes within 1 standard deviation of the mean to complete the race. So it becomes important in this section that at least we have a scientific calculator, and at least we practice more to work the mean, the standard deviation using the calculator. Right. As an exercise for all of us, we will look at, as an exercise, we will look at question, this question here, question 1. It says there, question 1. Look at it. I'm sure everyone can see the question. It's nice and clear to everyone. Now we are going to now write down. Please have a calculator next to you so that we can write it down as we answer this question here. The points received by the top 10 Premier Soccer League teams in no particular order are 56, 54, 40, 50, 36, 41, 41, 48, 58, 52. Now the first question says determine the mean points received. The first question says determine the mean points received. I'll give you time to work on the mean. Of course, we can use a calculator to do that. Determine the mean points received. Right, I'm sure we have done very well to calculate the mean. Then I'm sure we all agree that our mean is 47,6. The mean is equals to 47,6. The mean 47,6. We agree about that one. And then the second question now says, you have the data in your calculator. It says determine the standard deviation of the points received. The standard deviation. This is already the data is already in your calculator there. You went setup and then 2 statistics. You had 1 is a variable. There's a small table there, and the small table you inserted your data. You then now inserted your data. 56 is equals to 54 is equals to 40 is equals to 50 is equals to 36 is equals to 41 is equals to 41 is equals to 48 is equals to 58 is equals to 52 is equals to, we go AC, we go shift 1, it says 4 is variables. We want to check our numbers first. The number of terms is 10 numbers, we are happy. 10 numbers, we are happy. Then we want to check again now the mean as we have done. 4 is variable. The mean is 2 on the screen of the calculator. It says 47,6. We all agree about the mean. And then we still go AC, shift 1, 4, there is 4 variables, 4, and the standard deviation 3. Our standard deviation is 7,24. I'm sure we all agree the standard deviation 7,24. 7,24 is the standard deviation. Question 3. Question 3 now says on this exercise, look